In this video, we will generate the hyperbolic cosecant or values from 0.2 to 1.6. So it's array formula, hyperbolic cosecant of the x values 0.2 to 1.6, and we generate the Taylor polynomial expansion using the infinite product series, which is equal to the product of 1 over 1 plus x over pi n raised to the power 2 divided by x, where the value of n is from 1 to infinity. In this case, 9 is good enough. Now we calculate this portion, the array of this portion. So this is called the array formula. That is 1 over the quantity 1 plus, and this will be x over pi squared n squared. So the quantity x divided by the quantity pi times n. This is our n values from 1 to 9. N raised to the power 2. And enter. The value of x. This value of x will be 0.2 to 1.6. Now it's correct. So we go back to the formula. That is 1 over 1 plus x over pi n, all of them raised to the power 2. Now we can complete the formula, which is equal to product from 1 to 9, the array from 1 to 9 divided by x, and we'll drag this downwards, and we'll chart this. Insert chart, and we use scatter chart. Column is label, and in the series we show the trend line, the type polynomial, the degree 8. For the label, use the equation. We don't need a title, we already have the equation as the label. And here's the trend line and polynomial. You'll notice the trend lines are collinear. And the polynomials are almost the same. So 13.32 minus 67.8x plus 179x squared minus 262x cubed plus 209x to the fourth minus 67.4, and this one is minus 67.3. So there's an error now. Minus 17.1 minus 17.1 x to the 6, 18.9 x to the 7, 3.97 minus 3.97 minus 3.98 x to the 8. So as the power increases, there is an error. There's a slight error. That's because our n is only limited to 9. But if you want the error to reduce to 0, you increase the value of n from 1 to 100 or infinity. So this completes the use of the product function to generate the trend line and polynomials of hyperbolic cosecant and its infinite product series.